video, I'm going to go over the Intro to Energy Conservation that is page 28 in your packet. So when we talk about the energy conservation, what we're saying is that energy can neither be created nor destroyed. And in this case, they're talking about is a ball that is thrown straight up into the air and then it's going to come back down. So the only two types of energy that we are going to look at are potential and kinetic energy. And when we're working with these, what we're going to work up to is the equation for potential energy is mass times gravity times height. And the equation for kinetic energy is 1/2 mv squared. So the total energy of this system is not going to change throughout this whole experiment. But what's going to happen is the potential energies and kinetic energies will change, but they'll always add up to the same total energy. So what we want to do is start going through this. This first part here, it says a heavy ball is thrown into the air at 10 meters per second and has a mass of 2 kilograms. So they're throwing this ball up and eventually it's going to come back down. And if they're asking kinetic energy, the equation is 1/2 mv squared. So we could just start plugging in the variables we know. The mass is 2.0 kilograms and the velocity is 10.0 meters per second. Make sure you're squaring just the velocity. So now when you do this, 10 squared is 100. The 1/2 times 2 just equals 1. What you end up getting is 100 kilograms. Let me erase this. Meters squared per second squared, which is the same as a joule. So you get 100 joules. All right, that's the first part. It's just kinetic energy, pretty straightforward for that one. Now it's asking what is its potential energy at the start? Well, potential energy is mass times gravity times height. And at the start, the height is 0. So potential energy is 0 joules. As it gets higher, what happens to its speed? So imagine anytime you throw something in the air, it slows down as it's going up. So I would just say it decreases. Now, if its speed is decreasing, and kinetic energy is 1/2 mv squared, this velocity is decreasing. So its kinetic energy is going to decrease. As it gets higher, what happens to its height? It's just saying its height is increasing. So what's happening to its potential energy? That is also increasing because potential energy is mass times gravity times height, and you are increasing that height. Now at the very top, and sometimes this concept throws people off at first, at the very top of its ascent, what is its speed? So you throw this ball straight up, and right before it starts to come back down, at that very top point, for a fraction of a second, its speed is 0. And that's what that is getting at. That's right before it starts to come back down. So its kinetic energy at that point is 0 joules. Now this is the part that we've been working up to. What is the height that this ball reaches? And what we have to remember is that the total energy stays the same. So that means the maximum kinetic energy, which is at the start when you first throw the ball and it's moving its fastest, that is going to equal the maximum potential energy. And the maximum potential energy is at the height of this curve, right? So down here, that is max kinetic energy. And at the top, that is max potential. So what we are going to end up doing is setting potential energy equal to kinetic energy, right? Because the max potential equals the max kinetic. And we can write the equations in here. mgh equals 1/2 mv squared. Now when you're doing this, we can plug the numbers in. We know the mass was 2 kilograms. The gravity, since this is happening on Earth, is 9.8 meters per second squared. I need a little room here. And the height is what we're looking for. Now kinetic energy is 1/2 mv squared. And I should just put the data in here. The mass was 2 kilograms. And the speed that they gave us in the first part was 10.0 meters per second, and that part gets squared. So when you do this math, what you end up getting on the left is 19 kilograms meters per second squared, and on the right you have this 10 squared, which is 100, the 1/2 times the 2, so that was 100 kilograms meters squared per second squared. Notice the units are almost the same, except on the left, the meter's not squared, where on the right it is. And that's why we're going to end up getting meters at the end. It's 19.6. So now all we have to do is we want height by itself, so we divide both sides by 19.6. So the height should end up being, after you take 100 divided by 19.6, you get 5.1 meters as your answer. And the reason why the units work out like that, you have the 100 kilograms meters squared per second squared, and that is getting divided by the 5.1 kilograms. Now it's just meters per second squared, right? I'm just rewriting what I have here. So the kilograms cancel out, the second squared cancel out. Now you have meters squared divided by meters, so that one goes away, the squared goes away, and what you're left with just that meter. So we end up having 5.1 meters. Remember, the way we started this off is setting potential energy equal to kinetic, because that is what the law of conservation of energy is telling us. The max kinetic is going to be equal to the max potential energies. Now this one is saying we end up doing the same kind of thing, except it is a lighter rock. It's only 1.5 kilograms, so you're able to throw it with a higher velocity. And now they want us to do the same kind of thing. What is the height going to be now? So we have the potential energy, which is mass times gravity times height, equals the kinetic energy. Now I didn't show you this on the last problem, but if you want to make it easier, you can actually just cross out the mass. On both sides is 1.5 kilograms. So you're going to end up getting 1.5 kilograms divided by 1.5 kilograms at some point in the problem. So they could just cancel out. It makes it easier. So now what we have is gravity. We're going to rewrite this equation here. GH equals 1/2 V squared. Gravity is 9.8 meters per second squared. The height is what we're looking for. We're going to multiply that by 1/2. And the velocity in this case was 15 meters per second. And just that velocity is the thing getting it squared. So when you do this, this 15 squared, when you square that, you get 225. So you have this 1/2 times 225, and what you're going to do is divide by 9.8, because we want 9.8, we want to get rid of that, so we divide both sides by 9.8. What you should get for your height then is 11.5 meters. All right, so let me just do a quick write out for that. So what you end up having is the 1/2 times, times 225 meters squared per second squared, and all of that gets divided by 9.8 meters per second squared. And the same thing as the last problem, the second squared goes away, that meter goes away completely. You can take care of the second, so you have 1/2 times 225 divided by 9.8. So they're able to throw that ball quite a bit higher because it has less mass, so they could throw it with a higher velocity. Now number 3 is asking us for something different. It's asking us to solve for speed. They want to know at what speed is that rock going to hit the ground. Now they're throwing a 4 kilogram rock, so that's a bit heavier, and it only goes to a height of 8 meters in this case. So we have the same general idea. We're going to set potential energy equal to kinetic energy. So you have mass times gravity times height equals 1/2 mv squared. You can cross out the masses again because they would just cancel out anyway. And what you're going to have is 9.8 meters per second squared times the height, which is 8 meters, and that's going to give or equal 1/2 v squared. So now, if you want to solve just for v squared, what you have to do is get that v squared by itself. So I'm going to multiply both sides by 2. So now what you end up getting is v squared equals 2 times 9.8 meters per second squared times 8 meters. When you do that math, you get v squared equals 156.8 meters squared per second squared. And then if we want just velocity, we can take the square root of that. So velocity equals 12.5. And remember the unit, since you have meters squared per second squared, and you're taking the square root, the squares go away, and you get meters per second. All right, so you have to remember, law of conservation of energy. It means the total maximum potential energy equals the total maximum kinetic energy.